Thank you again for inviting me to talk at this very interesting webinar today. And it's also my pleasure to close the webinar with my talk, which will be, in fact, kind of a summary of what have been said today, and also it will link very much to one of the first lectures today, the lecture by Professor Zalewski, introducing ecohydrology to us. So what I want to talk about is ecohydrology and ecosystem approach to climate crisis, which is one of the three main crises that we are facing today. Along with the climate crisis, we also have the biodiversity and the pollution crisis, according to the UNEP. First of all, I want to I want to divide my speech into three parts. First, I want to talk about climate crisis shortly, then about ecohydrology and NBS, and then I want to put some questions to the future. To start with, I want to show you the state of the planet in 10 numbers, following one of the recent publications by Scientific American last week, and also the publication is related to the ongoing Committee of Parties conference now in the 28th COP in Dubai. So if we talk at where we are today, it's really not positive, because the world today is about 1.3 degrees Celsius warmer than in the pre-industrial time. We still keep producing carbon dioxide and other greenhouse gases, and the gap is almost 1 billion ton today. Still, we subsidize fossil fuel use, and we keep deforesting, which is one of the sinks, potential sinks for the CO2. At the same time, the annual rate of the sea level rise is more than 4 millimeters per year. The global economic losses from climate disasters since 1970 is more than $4 trillion now. We have very little time to act, because this is less than 6 years if we want to think at all about keeping the temperature between 1.5 degrees centigrade Celsius before the end of the century. We must invest in that process a lot. We must cut the emissions very quickly, and invest in the renewable power as soon as it is possible. So the challenges are high. We should be following one of those purple lines down there in the graph. As you can see, unfortunately, the current obligations of the country, or the current declarations of the country, are around this upper line. But this is still not the pathway we are following. We are actually following a pathway which is producing even more greenhouse gases now. So this is not positive at all. The effects we can all see. This is an example of the huge flood in Bangladesh in June this year, which left 33 millions of victims, many millions without houses and food. This is the flood in Emilia-Romagna, also early this year in May. Also, it left 30 people killed, 42 municipalities underwater, and billions of euro of the costs. Another problem is drought. This is also an example from just 2 months ago in Uruguay, where two huge reservoirs which are supplying the Montevideo with drinking water has completely dried out, and the people were left without the water, just buying the water in the bottles and protesting against climate change and the tensions in between different social groups that started to appear during this time. And especially this year is difficult, and the next year to come are also difficult because of the El Niño effect that is superimposing on all those processes. Additionally, all the problems that we can see with water are very much related to all other activities of humans. This is river regulation, for instance, or improper landscape maintenance, the nutrient leakage from the catchment to the river. So many different actions made by human in the area or in the catchment area, they are all adding to the problems that we are facing today. So didn't we know before about climate change and all the problems that are coming? Well, yes, we knew. Several actions have been taken 3 years, but as you can see, I'm pointing here only the really major international actions in this graph. It never stopped producing CO2. So what can we do? There are two lines of actions facing the climate crisis. The first one is mitigation, and it has to be done now. Mitigation is reduction of CO2 emissions and other greenhouse gases emissions. It's already, we may say, too late. But of course, it doesn't mean that we need to give up. It's just very, very important to start very efficient mitigation now. At the same time, we need to adapt. We need to adapt to already changing climatic conditions and to adapt to what have already happened and to what we know will happen today, even if we start the efficient mitigation now. So what is adaptation? Adaptation is the process to reduce the risk associated with climate change. It must be implemented through all means of actions, to policy, practice, projects at all levels of decision making. It must be a joint action between different decision making levels and the people. We must forget about business as usual approach and start looking at the world in a completely new way. So that will require learning from both people and organizations. Fortunately, the last report by the IPCC, as well as the last report of IPCC and IPBES, which is the International Platform for Biodiversity and Ecosystem Services, they have both underlined that global warming and protecting biodiversity are mutually reinforcing goals. They need to act together. So protecting biodiversity and protecting climate and adapting to climate is one action. They must be achieved together. This is because, well, giving just an example of one of the hypotheses about the biodiversity and ecosystem functioning, it is based on the fact that the better ecosystem functions, the higher biodiversity, the natural biodiversity of the system, the better ecosystem function. And the better ecosystem function, the more ecosystem services we receive as the society. So that's why in the recent strategies for climate mitigation and adaptation, you will find lots of ecosystem approaches, such as the nature-based solution or ecosystem solutions or green infrastructure or blue-green infrastructure or ecohydrology. So all those concepts are now very much present in the debate. And this is exactly where we are coming with our research to show all the options that you could have seen during this day today, how we can improve the quality of the ecosystems and at the same time adapt to the climate change. So when I think about blue-green infrastructure, I see it like as an infrastructure, as the physical space where all the processes take place, all the processes, ecosystem processes, which also support us as the society, so they provide ecosystem services. So it can be seen in a different scale context, so it can be seen as the European infrastructure, like here on the graph with the Nature 2000 sites, or the national scale infrastructure. As you can see here for Poland, these are the ecological corridors for Poland. In the region, in the city, what you can see here is the blue-green network, which was defined for the city of Łódź by the team of Professor Zalewski in the SWITCH project, or also very little implementations which can keep water and green right in the spot in the very, very selected places. What is very important for the blue-green infrastructure to work, however, as an infrastructure is first the connectivity, so it must be a connected system, then biodiversity, and then water. Blue-green infrastructure can be supported by nature-based solutions. We could have seen many examples of nature-based solutions that are tested at the university at the Ecohydrological Center in Poland. So these are all actions that come into this infrastructure to improve its functioning, to improve its efficiency. And finally, ecohydrology, as Professor Zalewski said at the very beginning, all the nature-based solution, all the ecological processes cannot take part if water is not there. And unfortunately, in the climate crisis, we are facing very often problem with the availability of the water and drought. So the water acting in the catchment must be taken very seriously to preserve water as much as it is possible. So with that background, let's say, I would like to show you my way of thinking about NBS and ecohydrology implementation in climate adaptations in 5 steps. The first step is to preserve nature. It's very important to preserve natural areas which are functioning well, especially the river valleys, wetland habitats, which are the places where the water is going to be present under the climatic crisis for the longest time. So all natural areas, or all even not natural but well-functioning areas, are very important to keep the coherence of the natural system. Here, I would like to encourage you to have a look at the initiative by Professor Wilson, which is called Half Earth, and also a very good book by Enrique Sala, Nature of Nature, which in a very nice way explain why the biodiversity is so important and the preserving nature is so important under the climatic crisis. The second step for me is to preserve water, to retain water. When I mean retention, I never have in mind the picture like this one here, like huge retention reservoir. What I mean is rather using the NBS and ecohydrological relationship in preserving water in each spot in the landscape. So the amount of money that one would be spending for this kind of the building, as you can see on the left side, this is a huge dam on a big river in Poland, would be the same if we invest in the restoration of wetland buffer zones along all the small and medium-sized rivers on 1/3 of the Polish area. This is the same price. Or in 1 million gates and dams on drainage ditches on the agriculture area. So the cost is the same. However, the retention of the water is several dozen times higher than the retention of the water in the reservoir, and several hundred times more than its retention reservoir. So the effect is much bigger with the same cost. We can receive very good result using nature-based solution and ecohydrology. The same important is preserving water in landscape by diversified vegetation. Here is the graph showing how the surface runoff decreases and the annual sediment yield decreases with more stable, more diversified vegetation in the area. So this is very much important. Then the third step would be to control nutrients. Actually, it can be done with the first 2 steps that I have presented. So restoring vegetation in the landscape, preserving the landscape, and restoring wetlands. It decreases the amount of the nutrients that is transported with a river downstream. This is an example from the research which was done on the Sulejów Reservoir, and here you can see on the left side the inflow to the reservoir of the river to the reservoir, and then the chemical effect on it. So you can see that after the very high inflow, there is a peak of the total phosphorus incoming to the reservoir, a peak of DOC incoming to the reservoir, and also here we can see the visibility in the reservoir. So you can see that the total phosphorus very much increases after each flat peak. The DOC increases during the high flow and then decreases, and the visibility in the system goes down very much. So the changes of the abiotic conditions in the reservoir, of course, will influence the functioning of its ecosystem, and especially in the lowland reservoir, it's very important to keep the nutrients down because of the risk of the toxic algae bloom. So also knowing this relationship, we can design both the landscape, the catchment, and the entrance to the reservoir in such a way that we can trap this high amount of the nutrients and prevent getting into the reservoir. This example you could have seen already in detail with in the presentation of Professor Frankiewicz, but this is also part of my third step, not control nutrients. It's important to control nutrients not only during its transport from the reservoir, from the catchment to the reservoir or to the river, but also to control nutrient allocation in the reservoir itself. And it can be done by the regulation of water level in the reservoir to control the trophic cascade in it. The third step is to restore the river. You could also have seen this example in the presentation of Professor Tomasz Jurczak. Our teams are very much involved in the activities related to river restoration. Now, this is an example from the river restoration in the city of Radom within the LIFE project that have finished a few months ago, but also another example of the river restoration from the city of Opoczno, where together with different interdisciplinary scientists and the society and the people living in there, we were preparing a concept for the restoration of a small river. The fourth step is nature to cities. This interaction between water, plants, and landscape is very well visible on this picture, which was made in June 22 last year in the Prague, where you can see the temperature surface of the town, which very much is related to the presence of water and green areas. So whenever the green area and water is present in the city, it very much influence on the local microclimate, so on the quality of life of the people in the town. This is just an example how the presence of water and vegetation works on the temperature, but how it can be done. This is also the several examples of the implementations that have been done in cooperation with our team in the city of Radom, and another one you could see in the previous presentation by Renata in the city of Łódź. Finally, the last thing is to remember that very often just protecting the nature or implementing the natural areas may be not efficient, maybe not enough in the face of the climate change. This is also something that Professor Zalewski said in his introductory presentation. So we must go beyond protecting. We must go for regulating. Implementation of nature-based solutions and implementation of ecohydrology is very important, and it is only possible after we really have a very good recognition of the area, of all processes that are influencing the ecosystem dynamic in the area. And this is just an example of the UNESCO IHP demonstration project on ecohydrology in the Police River in Poland that you have already also heard about today, showing how the different elements of the system must be understood in order to implement the efficient solutions. And finally, the last part of my presentation, future questions. We very often talk about how, adaptation and why it is important and why we should implement it. But from my perspective, one of the important questions is how long is adaptation possible? We know that adaptation has limits, which means points beyond which, despite of all the adaptive measures that we implement, the objectives of a given entity, group of people, or of a system, of natural system, cannot be protected anymore against the intolerable risks. The adaptation limits can be relative or absolute. Relative are those limits that maybe exist, but we don't know about them yet. And the absolute limit of adaptations are the limits where no adaptation measures are possible to avoid the risks. So my question is, where are the natural systems? We talk so much that the adaptation should be based on the nature-based solution or blue-green infrastructure, but these systems also undergo the impacts from the climate change. So how well can they still work for us, human, if we want to adapt? adapt at the temperature that is 1.3 degrees centigrade higher than in the pre-industrial area. And here I would like to go back to the theory of ecohydrology, to its first principle, which says that the dynamic of the ecosystem depends on water and temperature. And we know that water and temperature, the water availability, droughts and floods, and the temperature will change or is changing already under the climate change. And the other point, the key area of factors, the abiotic factors determine in the first place the dynamic of the ecosystem. And then only when they are predictable or stable or optimal, then the biotic factors take control over the dynamic of the ecosystem. And in that respect, I asked myself recently the three questions. The first one is, what are the limits for adaptation of natural systems under the change of those two key elements, temperature and water? Then, what is the efficiency of the NBS that we want to implement? We've been working on NBS for years, but for years, the boundary conditions, which is water and temperature, are changing. And we know already, and you could hear this in today's presentations, for instance, in the presentation of Agnieszka Bednar, that now we have to think about how those NBS can be adapted to be still efficient. And this is my third question, how we can optimize our NBS to support nature-based solution and to support nature in the adaptation to the negative scenario of the climate change, to make sure that we can still have adaptation in place. Thank you very much, and I leave you with those three questions, maybe for your future consideration. Thank you very much.